Okay, so my next guest today is Kevin Brennan from Indium Corporation. Nice to meet you, Kevin.
Thanks for having me.
Okay, so we're going to talk about a couple of products here today. First is the Durafuse HR. It's been around for about a year now, but it's geared for the high reliability market. What specifically, first of all, before we get into the actual composition, what applications are you looking to use this in?
I'd say we're finding that it's very useful in the automotive industry. Anywhere that your circuit boards may be exposed to a wide variety of elements, very cold, very hot, and your circuit boards or your electronics might be exposed to thermal cycling. It's a very rigid, high reliability alloy that excels in those type of environments.
It's a lot more flexible in that area and it's a lot more flexible than your other Durafuse LT.
So actually the HR is rigid and the LT is very flexible ductile. So
I see.
It's an important distinction because when it comes to high reliability applications, there are some times where you need some flexibility, some ductility.
Yep.
If you have wafer level CSPs or anything with high CT mismatch, the Durafuse LT low temperature really excels because it's able to kind of absorb those stresses.
Yeah.
And the Durafuse HR is much more rigid, so it works much better in application where you don't have those types of components. So very traditional PCBs, it works very well there.
So what did you do to make up this the HR, make the high reliability alloy? What's the alloy composition of the Durafuse?
Sure. So it utilizes our Durafuse technology, which is two alloys in one solder paste. And the challenge with high rel is once you add those dopants, so you start with SAC tin silver copper.
Yep.
You may add some bismuth, antimony, indium, nickel dopants.
Yep.
It's very common in high rel.
Yep.
But then you start to struggle with voiding. So what we did was utilizing the Durafuse technology, we're able to still have that high rel composition, but drive down the voiding because we have two different melting points. So the first alloy will melt, it'll wet to the substrate, it's going to wet to the underside of your component. And what it's also doing is it's wetting to the second alloy B, that melts later on. But because you have a molten alloy wetting to that, you have diffusion occurring. So you're able to actually melt the second alloy below its traditional melting point through the use of diffusion.
So basically, but the melting point of the second one is what, 220?
So with the Durafuse HR, the first one melts at 215 Celsius, and the second alloy actually melts at 229. 229. But you get full melting, fully homogeneous at 220, 221. So.
Yeah, interesting. Okay. Good. So then you've also introduced, I believe, a new flux vehicle recently. What is the name of the flux and what's its application?
Sure. Yeah, that's Indium 12.9 HF.
Okay.
It was designed specifically for Type 5 fine pitch, high density boards. Yeah. So we're looking at great transfer efficiency. It's a no clean flux, but we really want to make sure it's still usable in air. So once you get to the Type 5, you run into a lot more surface area, more oxidation. So we want to make sure no graping, even in air reflow. So that was a big focus for us.
Right.
And then on top of that, we found that it's actually compatible with SAC 305 or any SAC alloy, Durafuse LT and Durafuse HR. So it's very versatile. You can use it kind of in multiple different applications.
Multiple applications. Okay. Well, it sounds very versatile, that's for sure. Okay. So Kevin, one of the other applications you've got is on the LT side, I believe, for some data center applications. Can you talk a little bit more about that?
Sure. Yeah. So Durafuse LT, like we said, it's very ductile, and it also enables people to reflow below standard SAC peak temperatures. So those two are very key as the chips are getting massive. Right now we're seeing it's very common 60 by 60, but in the future they're getting well over 100 by 100.
Right.
And with that comes some very complex warpage.
Yes.
So if you're able to reflow at a lower peak temperature, that warpage might not be as extreme, and it's able to kind of, instead of redesigning your whole board, you switch your alloy over, fine-tune your reflow profile, and hopefully keep that warpage low enough to avoid any non-wet opens, head and pillow style defects. And then once you have it built, the reliability aspect, because of that warpage, those stresses are built in.
Yes.
the ductility comes in handy there, where it's able to absorb those
absorb the movement,
stresses.
because inside these data centers, the thermal excursions are pretty extreme.
Right. Yeah.
Yeah. So I mean, it needs that sort of flexibility in there for sure.
Yeah.
Yeah. Excellent. Well, it sounds a really interesting product. Great. So we've got obviously Productronica coming up just in a couple of weeks. So have you got anything new coming out for that, or is this going to be the main products that you're going to be?
So at Productronica, we're going to be showcasing a lot of our products. So here we really focus on solder paste, solder wire, because SMT.
Yeah,
but at Productronica, we're going to be showcasing our sinter applications, our formic acid reflow paste, our power. If you're familiar with our preforms, informs, we're showing everything across the board. A lot of automotive focus for sure, and
well, especially in Germany, there's, as you say, a lot of automotive, a lot of power applications. So that makes sense. So. We'll look forward to that. So hopefully we'll catch up with you again in a couple of weeks. But thank you for coming in today.
Thanks for having me.
For micro dispensing, there is one product line that is proven and trusted by manufacturers in semiconductor packaging, electronics assembly, medical device, and electromechanical assembly the world over. DL Technology, superior pumps and needles for the finer things in life.